What is breakdown voltage for diodes and transistors? Imagine a tiny electronic switch that can handle a certain amount of voltage before it stops working properly. That's what breakdown voltage is all about. It's a key point where a diode or transistor can no longer block or control current safely. When the voltage across the device gets too high, it causes a sudden surge of current that can damage the component. This is called junction breakdown. For diodes, breakdown voltage happens when the reverse voltage applied across the PN junction reaches a specific level. There are two main ways this can happen. One is avalanche breakdown, which occurs in diodes with lighter doping. When the reverse voltage is high enough, it accelerates charge carriers so much that they knock loose more electrons and holes, creating a chain reaction. This causes a rapid increase in current. The second way is Zener breakdown, which happens in heavily doped diodes. Here, the electric field is so strong that electrons can quantum tunnel through the depletion layer at lower voltages. Zener diodes are made to take advantage of this effect to keep voltage steady. The actual breakdown voltage depends on how the diode is made. Factors like doping levels, the material used, and the size of the device all matter. Silicon diodes usually have breakdown voltages from about 50 to 100 volts or more. Zener diodes can be designed with breakdown voltages from just a few volts up to several hundred volts, with tight control over the exact voltage. In practical electronics, Zener diodes are used to regulate voltage. They keep circuits stable by maintaining a constant voltage once they break down. Avalanche diodes are often used for protecting circuits from overvoltage situations by safely shunting excess voltage away. When it comes to transistors, breakdown voltage is the maximum voltage you can apply between certain terminals, like collector to emitter or collector to base, without causing damage. If the voltage exceeds this limit, the internal junctions can enter a breakdown region. This leads to uncontrollable large currents flowing through the transistor, which can destroy it. Manufacturers specify these breakdown voltages in datasheets. They depend on how the transistor is built, including doping and structure. Engineers need to make sure their circuits stay below these limits to keep transistors working reliably. In summary, breakdown voltage is a critical number for both diodes and transistors. It tells you the highest reverse voltage they can handle before they start conducting excessively and risk damage. Knowing this helps in designing circuits that last longer and work more safely. Whether you're working on analog electronics or embedded systems, understanding breakdown voltage is essential to protect your components and ensure your projects run smoothly.